Here's an exercise. Determine the output of R of 4, where R is this method right here. So first of all, R clearly has a base case when I is less than 0, and its method calls, its recursive calls, are clearly getting closer and closer to the base case, since I minus 1 is closer to being less than 0 than I is. So then, the output of R of 4 would be, first it prints 4, then afterward executes R of 3, then prints 4. Then what does R of 3 do? It prints 3, executes R of 2, then prints 3. Then what does R of 2 do? Prints 2, executes R of 1, then prints 2. Then what does R of 1 do? It prints 1, executes R of 0, then prints 1. Then what does R of 0 do? Over here, it's not yet the base case. It still does the prints 0, executes R of -1, and prints 0. Then what does R of -1 do? Well, up here, that's when I is less than 0. It does nothing. So then, now back to R of 0, executes R of -1, does nothing over here. So R of 0 just prints 2 zeros. Then R of 1 prints 1, executes R of 0 and prints 1. Well, executes R of 0 can be replaced with prints 0 and prints 0. Then similarly, in the call of R of 2, executes R of 1 can be replaced with prints 1, 0, 0, 1. Then we can do that all the way up. So R of 2 can be replaced with printing 2, 1, 0, 0, 1, 2. Executing R of 3 is the same thing as printing 3, 2, 1, 0, 0, 1, 2, 3. And then the output would be 4, 3, 2, 1, 0, 0, 1, 2, 3, 4, as shown below. Here's another exercise. Determine the output of x of 3, where x is this method right here. So at a first glance, there doesn't appear to be a base case, but there actually is. A base case is a case where the method itself is not called again, so there's no recursive call. So basically, we don't want this thing in the base case. So now, when is this thing executed? Well, it's executed inside the for loop n times. So we notice that when n is less than or equal to 0, then the for loop doesn't execute, in fact. So then that means that n is less than or equal to 0 is the base case. And now, is everything getting closer and closer to the base case? Well, let's see. X of I. Well, I is less than n, so then therefore I is closer to being less than or equal to 0 than n is. So x of I is getting closer to the base case. So therefore, this is getting closer to the base case because I is less than n. Now let's determine the output. So first of all, x of 3. What does that thing do? Well, let's run through this. N is 3, so it basically executes x of 0, executes x of 1, executes x of 2, and then that's it, because that's what this for loop does. Then afterward, it prints 3. And now, before we know what x of 3 is, we must know what x of 0 is, so let's take a look at that. X of 0, well, it doesn't execute the for loop at all. So then we basically just print 0. And now, again, we're done with x of 0, but now we need to know what x of 1 does. So what does x of 1 do? Well, first of all, through this for loop, it runs x of 0. So executes x of 0. Then prints 1. But we already know what x of 0 is. That's just prints 0 right here. So then x of 1 is just prints 0 and then prints 1. And now we're done with x sub 0 and x sub 1, but we still need to know what x sub 2 does and before we know what x sub 3 does. So then let's do x sub 2. So what does that do? Well, through this for loop, it first runs x sub 0 and x sub 1. Then afterward, through that last print statement over there, it prints 2. So what is that? Well, executes x sub 0 we already know is prints 0. Executes x sub 1 is really just prints 0 and then prints 1. So then x sub 2 is really just printing 0, 0, 1, 2. So now we know what everything does. So we know what x sub 0 does, we know what x sub 1 does, and we know what x sub 2 does. So now we should be able to know what x sub 3 does. So x sub 0 is just prints 0. X sub 1 is just prints 0 and prints 1. X sub 2 is just prints 0, prints 0, prints 1, and prints 2. And the output is 0, 0, 1, 0, 0, 1, 2, 3, as shown below. Here's another exercise. Determine the output of a of 3, where a is this method right here. So first of all, initially, it doesn't seem like recursion because a is calling b. But then we notice that b is calling a as well, so it actually is recursion. And now let's look at the base case. So the base case is I is less than 0, as clearly stated here. There's definitely no recursive call anywhere. Otherwise, there's going to be a chance of a recursive call from b of I. And b clearly doesn't have any base case on its own because it calls a no matter what. So b's base case relies on a. So now, let's determine the output of a of 3. So a of 3, well, that prints 3, and then executes b of 3. What does b of 3 do? Well, that executes a of 2, then prints 3. Then what does a of 2 do? Well, that first prints 2, then executes b of 2. Then what does b of 2 do? Well, that executes a of 1, then prints 2. And what does a of 1 do? That prints 1, then executes b of 1. Then what does b of 1 do? That executes a of 0, then prints 1. Then what does a of 0 do? It prints 0. Then executes b of 0. And what does b of 0 do? Well, up here, it executes a of negative 1. And then afterward, prints 0. Now, what does a of negative 1 do? So, we see that I is less than 0 now, so we just return, so it does nothing. So now, when we go back to b of 0, we see that executes a of negative 1 is the equivalent to not having it. Then, what does executes a of 0 do? Well, it prints 0 and then executes b of 0, and executes b of 0 is just prints 0. Then similarly, we can replace a of 0 in b of 1, and we can continue this. And then output is 321000123, as shown below. Here's another exercise. Determine the output of u of 2, where u is this method right here. So first of all, what's the base case? Well, although there appears to be a base case right here, if n is less than 0, then return. That's actually not a base case. Well, why? Well, there is something before it. The base case should be the first thing that's checked. And why is that? Well, as we recall, base case should satisfy the property that there's no recursive calls. So basically, if n is less than 0 was the base case, then that would mean that there would be no recursive calls. However, this is a recursive call that's going to happen. And as a matter of fact, no matter what n is, no matter when I call u and how I call u, it's always going to call u of n minus 1. So therefore, there is no base case, so therefore this is an endless recursion. And if we do it using our method we've done, u of 2, what does that do? Well, that executes u of 1, and then prints 2. What does u of 1 do? Well, that executes u of 0, and then that prints 1. What does u of 0 do? Well, that executes u of negative 1, and then prints 0. What does u of negative 1 do up here? Well, it executes u of negative 2. And although it doesn't execute this print statement, it still executes u of negative 2 because it's before the if statement. Then u of negative 2 executes u of negative 3, and we get a problem. It's going to go down forever because there is no real base case. Here's another example. Determine the output of the following, where v is this method right here. So how do I do that? Well, we clearly see that there's a base case, which is a equals 0 and b equals 0. So then, and everything is getting closer to the base case, assuming a and b are positive or non-negative, which we are assuming because we're calling v of 2 comma 3. Now let's determine the output. So v of 2 comma 3, well, that first is returns v of 1 comma 3 plus v of 2 comma 2. And now what does v of 1 comma 3 do? Well, returns v of 0 comma 3 plus v of 1 comma 2. So then what does v of 0 comma 3 do? Well, that just returns 1. And what does v of 1 comma 2 do? That returns v of 0 comma 2 plus v of 1 comma 1. And what does v of 0 comma 2 do? It returns 1. And then what does v of 1 comma 1 do? Well, it returns v of 0 comma 1 plus v of 1 comma 0. So then what does v of 0 comma 1 do? Well, that returns 1. What does v of 1 comma 0 do? Well, that returns 1. So then we know what v of 1 comma 1 does. That just returns 1 plus 1, which is 2. So then now we know what v of 0 comma 2 and v of 1 comma 1 is. So then this thing is 1 and that thing is 2. So then that's 3 overall. And now we know what v of 1 comma 3 is. That's just 1 plus 3, which is just 4. And now we know what v of 1 comma 3 is. And now what's v of 2 comma 2? Well, let's do that now. V of 2 comma 2, well, that just returns v of 1 comma 2 plus v of 2 comma 1. Notice that we already know v of 1 comma 2 up here. However, we don't know v of 2 comma 1, so let's just do that. V of 2 comma 1, well, that just returns v of 1 comma 1 plus v of 2 comma 0. And we know that v of 1 comma 1 returns 2, so what does v of 2 comma 0 do? Well, that just returns 1. So then this is 1, so 2 plus 1 is 3. This thing is 3. 3 plus 3 is 6. So now we know that v of 2 comma 2 is 6. And now 4 plus 6 is 10. So the answer is 10 as shown below. And here's another example. Determine the output of C of 5 when C of 5 is printed, given that C is this method right here. So there is a base case. It's if n equals 1, or if n equals 2, then it returns 1. And notice that even though there's something before the base case, that thing doesn't include any recursive calls, so we're fine. So now let's do this. C of 5. So what does that do? That prints 5 and then returns C of 4 plus C of 3. So then what does C of 4 do? That prints 4 and returns C of 3 plus C of 2. What does C of 3 do? Well, that prints 3 and returns C of 2 plus C of 1. What does C of 2 do? That prints 2 and then returns 1. And what does C of 1 do? That prints 1 and then returns 1. So now we have returned C of 2 plus C of 1. So what does C of 2 do? Well, first of all, that prints 2 and then returns 1. Notice that it still prints even though it's being treated as a value. And then C of 1, well, that prints 1 and returns 1. So C of 3 just returns 1 plus 1, which is 2. And now over here, C of 3, well, prints 3, prints 2, and prints 1. And then returns 2. C of 2 over here, well, that prints 2 and returns 1. So this thing overall returns 3. Then afterward, this thing, we know what C of 4 is. So returns C of 4, which is first prints these things, then returns 3. Then what does C of 3 do? Prints 3, 2, 1, then returns 2. And 3 plus 2 is 5. So now, what does system.out.println of C of 5 do? Well, that does all of this and then prints what C of 5 returns, which is 5. So then the result is 5, 4, 3, 2, 1, 2, 3, 2, 1, 5, as shown below. 5, 4, 3, 2, 1, 2, 3, 2, 1, 5.